These are few questions taken from topics like numbers and arithmetics, which will give you a good practice for non-calculator paper. The question says find the value of 5 raised to 0. Any number raised to 0 is equal to 1 as per the rule of the index, where the number should not be 0. So using the rule here, 5 raised to 0 will be 1. The square root of 64. Well, 64 is a square number. You get it by multiplying 8 times 8. So square root, finding the square root is like the reverse operation of squaring a number. So the square root of 64 is 8. The cube root of 64. Well, 64 is a cube number as well. You get it by multiplying 4 times 4 times 4. Or 4 cubed is 64. The cube root is like reverse operation of cubing a number. So the cube root of 64 is 4. At this point, I would like to remind you that you need to remember all the square numbers and the square roots also. Square numbers and their roots, cube numbers and their roots as well. So you have to remember from 1 till 20, the list of all the square numbers, like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 gives you 9. So all these are the list of square numbers all the way up till 20, if you remember them. And cube numbers from 1 till maybe 15. Yeah, if you remember them, it will be easier for you to solve such questions. The next question says, write down a common factor of 15 and 27, which is greater than 1. So a factor of 15 is a number which divides 15 completely. Or in other words, what are the numbers which multiplies to give the answer 15? So we have this pair, 3 times 5 gives you 15. So 3 and 5 are the factors of 15. Both 3 and 5 divides 15 completely. And similarly for 27, what are the factors of 27? We have 3 times 9 gives you 27. 3 divides 27 completely. 9 also divides 27. So these are the factors. Now it wants you to find a common factor which is greater than 1. So we see the number 3. The factor 3 is present for both these numbers. So 3 is a common factor for 15 and 27. Now a common multiple of 10 and 12. Multiples are the numbers which appears in the list of in the timetable of a number. Like 10 times 1 gives you 10. 10 is a multiple of 10. 10 times 2 gives you 20. So 20 is a multiple of 10. 30, 40, 50, 60. All these are the multiples of a number. And then what about 12? The multiples of 12 are 12 ones is 12, 12 twos is 24, 12 threes is 36, 48, 60. These are the multiples of 12. A common multiple for 10 and 12 is 60. You can go ahead and watch my videos where I have explained about the concept of factors, multiples, and square numbers, cube numbers, prime numbers. I will link the video in somewhere here. Next question says, 2 of the factors of 2007 are square numbers. So one of these is 1. Well, find the other square number. So we have to find, for this question, to answer this question, you need to know what do we mean by a factor? What do we mean by a square number? So for 2007, it says that there are 2 factors, and 2 factors, they are both square numbers. One of them is 1. Well, 1 is a square number, we know that. What is the other square number which is a factor of 2007? Or in other words, what is that square number which divides 2007 completely? So if we try to figure out what are the factors of 2007, well, 2 is not a factor. What about 3? If we add all these digits to check if if this number is divisible by 3, we need to add all the numbers. 2 plus 7 is 9. 9 is divisible by 3. So yes, 3 is one possible factor of 2007, but 3 is not a square number. But from 3 we can assume maybe 9 could be a factor of 2007. So let's check. 2007 divided by 9. Does it divide it fully? So 9 goes in 22 times. 9 twos is 18. We have 2 remaining. We can bring down the 0. 9 twos is 18. We have remainder 2, and then 7, 9 threes is 27. So here 9 divides 9 divides 2007 fully. So 9 is a factor of 2007, and also we know 9 is a square number. So the number other than 1, which is a square number and a factor of 2007, is 9. The next question says, write down the two factors of 2007 which are prime. We have to now figure out any two factors of 2007 which are prime numbers. Now you need to know what is a prime number. A prime number has only two factors, 1 and the number itself. It doesn't have any other factor. So from the above question, we have seen that 3 is a factor of 2007, and we know 3 is a prime number. Let me list the prime numbers here, a few of the prime numbers. So prime number starts with 2. 2 is the first prime number. The next is 3, 5, 7, 11, 13, 17, 19. All these are, and there are many more. So these are the prime numbers. Here you see, if you try to find out the factors of each and every number, there will be only two factors. The factors of 2 is 2 and 1. 2 times 1 gives you 2. There is no other number which multiplies or which gives you the answer to by multiplying any two numbers. So we have 3 also as a prime number. 5, like 5 times 1 gives you 5. There is no other number which multiplies to give 5. There is no other whole number which multiplies to give 5. So these are all prime numbers. Now you have to figure out any two prime factors of 2007. One of them is 3. What about the other prime factor? Well, you can use the previous question again. We have seen 9 divides 2007, and giving you the quotient 223. So that means 223 is also a factor of 2007. Because 9 times 223 gives you 2007. And 223 is a prime number. So 223 is another prime factor of 2007. Write down a multiple of 4 and 14 which is less than 30. Well, we can write the list of all the multiples of 4 and 14. So the first multiple of 4 is 4 ones is 4, 4 twos is 8, 4 threes is 12, 4 fours 16, 4 fives is 20, 4 6 is 24, 4 sevens 28, 4 nines 32, 4 eights is 32, and there are many more. What about 14? 14 ones is 14, 14 twos is 28, and there are many more. We can see here the common factor for 4 and 14 is 28. These are the list of numbers given to us. From this list, we need to write down the smallest number. So of these numbers, we know that on the number line, the negative numbers are the least of, so they are smaller. So the number which is further to the left side on the number line is the least of them. So, well, we can check between -4 and -16, which is the smaller, or the number which occupies the leftmost position on the number line, which is -16. So that's the smallest of them all. You have to pick a natural number. A natural number are the numbers which are like the counting numbers, which are positive whole numbers also, I can say. So any whole number, we see 7 and 144. These are positive whole numbers. You can pick any one of them. I'm using 7 as a natural number. A square number. Square number is the answer when you multiply any two numbers together. When you multiply a number to itself. Like 2 times 2 gives you 4. 4 is a square number. So from this list, which of them is a square number? 144 you get by multiplying 12 times 12. 12 times 12 gives you 144. So that 144 is a square number. An irrational number. An irrational number is one which cannot be expressed, you cannot write it in the form of a fraction like x over y or p over q. So, in other words, if you express a number as its decimal, it will be non terminating, it will never end, and it's non repeating, it doesn't recur, it doesn't follow any pattern. So, this is the definition of an irrational number. Like, it cannot be expressed as a fraction, or I would say, to be more precise, a number when expressed as a decimal, it should not terminate, it will not end at any point, and it will not follow any pattern when the digits you're expressing in them as a decimal value. So from these numbers you see, well, -4, -16, they are integers. Integers or whole numbers are rational. Well, 0.12, the number here, is like a terminating decimal. That's also a rational number. 2/2, it's already expressed as a fraction. That's a rational number. The only number which remains here, which cannot be expressed as a fraction, is √7. So that's irrational number. If you try to find its decimal equivalent value, the answer you will see, the number will never end and it will not have any pattern. None of the digits are repeating, or they don't follow any pattern. The next question, write down 40 as a product of prime numbers. So I will write 40 as a product of prime factors. To write that, I will use the factor tree here. So, well, I can pick any two factors of 40. There can be 2 and 20. And then I circle the number which is prime and I split the one which is not prime. 20, again, I can write it as a factors in terms of its factors. 2 times 10 gives me 20. These are the factors of 20. 2 is a prime factor, 10 is not, so I split it. 2 5s gives me 10. They both are prime, so I circle them. So all the numbers I've circled are the prime numbers, or in other words, they are prime factors of 40. So 40 as a product of prime numbers can be written as 2 times 2 times 2 times 5. 3 pairs of prime numbers have a sum of 40. One of the pairs is 3 and 37. Find the other 2 pairs. So if I list the prime numbers, which gives me a sum of 40, so that means the number has to be less than 40 for sure. So what are the prime numbers? We have 2, 3, 5, 7, 11, 13, 17, 19, and then 23, 29, 31, 37. Well, these are the primes which are less than 40. So we have to pick any two numbers which will add up to give me the answer 40. One of them is already done for you, 3 and 37. So you add 3 to 37. 3 is a prime number and 37 is a prime, which is there in this list. When you add them, you get the sum 40. So what's the other pair here? So excluding 3 and 37, what's the other pair we can use? Well, I see I have 31 here. Do we have any other number which adds up to give the sum 40? It doesn't look like 31 is added to any number to give 40. Well, I can go with 29. Check with 29. Well, there is 29. I can use 11 with it and check if it's giving me sum 40. 9 plus 1 is 10. That's a 40. So 29 and 11 is another possible pair of primes which adds up to 40. So I have used them. What else can I use? There's 23. 23, if I add it to either 7 or 17, let's check with 17. 23 and 17, if I add, am I getting 40? Well, yes, I do get 40 here. So 23 and 17 is another possible pair of primes which add up to give 40. X is an integer between 60 and 90. Write down the value of x when it is an odd square number. So, well, I can list all the numbers from 60 and 90 and pick up the number which is odd and a square number. Well, so 60, 61, 62, 63, 64, 65, 66, 67, 68, and there are many more. Well, you can keep doing that. Or you can see what is one odd number. We can find the list of square numbers here, which is between 60 and 90, and it has to be an odd number. Well, we know from this list 64 is one odd, sorry, I will write it here. So for this question, the square numbers between 60 and 90 is 64, 8 is 64. What is the next square number? Well, 64 is not odd. So the other square number between 60 and 90 is 9 nines is 81, right? And we see 81 is between 60 and 90, and it is an odd number as well. So this is our answer. What is the value of 4 cubed? Well, all these are questions for this. These are the follow-up questions for the same thing. So you need to pick up the answer for this from this list. 4 cubed is 4 times 4 times 4, which is 64. A multiple of 29. What number you get in the timetable of 29? So 29 times 2 gives you 2 nines is 18, 2 twos is 4, 58. Well, 58 is less than 60, so this is not the possible answer. Let's go with 29 times 3. 3 nines is 27, 3 twos is 6, 7, 87. So 87 is between 60 and 90. It is one possible number in our list, and that's a multiple of 29. So 87 is the answer for this. A prime factor of 146. What is the factor of 146 which has to be a prime number? So, well, we know 146 is the prime factors, or the number which divides 146 fully, and that should be a prime number. Is like we can divide it by 2. 2 sevens is 14, and then we have 6 here. 2 threes is 6. So 2 times 73 gives me 146. 2 is a prime number. 73 is also a prime number. But 2 is not between the list, the mentioned range of numbers. But 73 is between the range 60 and 90. So the answer here is 73. There's another list of numbers given here. From the list, write down a prime number. Well, 4 is not a prime number. Root 8, well, we cannot find square root of 8. It's an irrational number, to be more precise. What about root 25? The answer for root 25, the square root of 25 is 5, which is a prime number. So when you evaluate this, you're getting a prime number. So I can use root 25 as a number which is a prime number from this list. And you have to pick an irrational number. Well, all of them are rational. They can be expressed as like in the form of a fraction. 0.333, that's all. Although it's such questions in such numbers never end, but then they follow a pattern. So that's also a rational number. Irrationals are those which are non-terminating and non-repeating. They will not have any pattern when expressed as a decimal. So the answer to this is under root 8. The diagram shows how the water level of a river went down during a drought. So if I take a vertical number line to represent the water level here, 0 shows that it's the sea level. The numbers above it, the positive numbers shows the water is above the sea level, and the negative numbers here suggest the water is below the sea level. So initially the level was at this point, that's at 1 meter. Now it went down due to drought. somewhere here, which is between -2 and -3. So I will take this as minus 2.5. By how much, by how many meters did the water level go down? So from 1 to -2.5, how much has it gone down? What's the decrease here in the level of water? So it's 1 meter. It went down by 1, 2, 3.5. So it's a 3.5 meters it went down. A heavy rainfall followed the drought and the water level went up by 1.6 meters. What was the water level after the rainfall? So now it's at minus 2.5. It went up by 1.6. So you add 1.6 to minus 2.5 to find the new level of water after the rainfall. So this is so you minus 2.5 and 1.6. One of them is positive and another is negative number. So we have to subtract them. You take away 6 from 15 to get 9. That's a 0. So that's a minus 0.9. So the new water level after the rainfall is somewhere here. It's minus 0.9. So it should be somewhere here. The temperatures at sunrise and burn on 7 days of 1 week were recorded as follows. List the days on which the temperature at sunrise was less than -3. Now, which of these temperatures is below -3 degrees? If I use a number line to show these temperatures, suppose -3 is somewhere here. Well, there is a 0. -1 is just above 0, so here it will be. So it's not below 3, it's above -3. So and then -7 is below -3, somewhere here towards the left side. -6 is here. 1 and 3, they are positive, so they will be to the right side of 0. -4 will be further down here. It's just next to -3. So we see these are the values, these are the numbers which is below -3, further to the left side on the number line. So which is on Monday, Tuesday and Saturday. So these were the days which recorded a temperature below -3 degrees. Work out the mean or average of the 7 temperatures. To find the mean, we add all these values and divide with the total number of the days here. So when we add them, I can add all the negative numbers together and then positive. So -1 plus -7 is a -8, -8, -4 is -12, -12, -6 is -18. And then 1 plus 3 is a +4, and all of them divide by 7. So 4 is being added to -18 to get -14 over 7. So that's a -2. The answer is that the average or the mean of all these temperatures is -2. Work out each of the following as a decimal. So you need to convert these numbers in decimal. So 28%, so it's equivalent to saying 28 over 100 as a fraction. Now this as a decimal, so to convert the 28 over 100 as a decimal, you need to shift the decimal 2 places to the left. So that's 0.28. So when you divide any number by 10, so you're shifting 1 digit to the left. You are shifting the decimal 1 place to the left. So it's 2.8. You divide it by 100, you shift 2 places to the left. So it's 0.28. Divided by 1000, you're shifting 3 places to the left. So it's 0.028. Well, when we multiply, it reverses. The direction of the decimal will reverse, so it will go to the right. So if it's like 2.8 times 10, you're shifting the decimal 1 place to the right, which will be 28. So 2.8 times 100, the decimal goes 2 places to the right, so that will be 280. So this is the convention we follow when we divide or multiply by 10, in multiples of 10. So now using the same convention, 275 over 1000. here we are dividing by 1000, so we shift the decimal 3 places to the left. So this will be 0.275. The above number is 0.28 here. The next number is a fraction. You need to convert it into a decimal. 2 over 7. Well, I can divide 2 by 7. So here I divide 2 by 7 to see its equivalent decimal. So I'm using the long division here. 2 is lesser than 7, so I take a decimal, put a 0 here. 7 goes in 22 times. 7 twos is 14. When I subtract, I get a remainder 6. I can take a 0 here. 7 goes in 60, like 7 eighths is 56. I get a remainder 4. Again taking a 0, 7 fives is 35. I get a remainder 5. And then 0, 7 sevens is 49. I get a remainder 1, 0, 7 ones is 7. I get a 3. And it looks like it's going to repeat forever. Well, after a few digits, the pattern will repeat here. So it's a recurring decimal. So we can stop here. Well, it did not mention us to write to any specific decimal value. So I can write this as 0.28571. Now it wants you to arrange these numbers, these three numbers, in order of size with the smallest first. So we have already found the equivalent decimals of these numbers. So out of these three values, we see this is the smallest. So 0.28, 0.27, 0.2857. 0.27 is the least of them, which is 275 over 1000. The next is here, it's a terminating decimal, which is 28%, and 2 sevenths is the largest of them all. George's phone card lasts for 300 minutes. He has used 3/5 of this time. Work out how many minutes are left on his phone card. So he used 3/5 of 300. How much is left? Well, the remaining time will be 2/5 of 300. If you've used 3/5 of the fraction, then 2/5 of that will be remaining. So if we find 2/5 of 300, we can directly find the number of minutes remaining. So 2/5 of 300, like 1/5 of 300, or 300 over 5 is 60. 60 times 2 gives me 2/5 of 300, which is 120. 4 cube take away 5 square. So 4 cube is 4 times 4 times 4, which is 64. Take away 25. 5 square is 25. So if you subtract 25 from 64, what do you get? So this is 14, and that's a 5. 14 take away 5 is 9. And then we have this 39. The next question says the Dead Sea shore is 395 meters below sea level. So below sea level suggests that it's a negative number. It's minus 3.5 meters. Hebron is 447 meters above sea level. So that's a positive number because it's above sea level, above 0 on the number line. Find the difference in height. So what is the difference in the height of these two places here? So from 447, the difference, when you're finding the difference, you take away this minus 395. So it's as good as you're adding 395 to 447 because you're subtracting a negative number from another number. So this will be 447 plus 395. 7 plus 5 is 12, and 9, 10, 14. That's an 8. So it's 842 meters. The difference in the height of these two places is 842 meters. Write as a fraction in its lowest terms. So 75% is equivalent to 75 over 100 as a fraction. In its lowest form, you can simplify the numerator and denominator by dividing by 5. 5 goes in 75 15 times. So 5 once is 5, 5, okay, 15 over 20. 5 goes in 120 times. We can simplify it further by dividing by 5. 5 goes in 15, 3, and 5 goes in 24. So 3 quarters. 75% is equivalent to 3 quarters in terms of a fraction. What about null point 0.07 as a fraction? Well, I need to first eliminate the decimal. To eliminate the decimal, I need to times it by 100, and then I divide by 100 to make it its equivalent form. So 7 times 100 is null point 0.07 times 100 is a 7 over 100. So 0.07 is equivalent to 7 over 100 as a fraction. Well, you cannot simplify this further, so this is already in the simplest form. So that's the answer.